Hello everyone, my name is Zahid Ilkal. I am product manager at Commvault Systems. Today we're going to talk about some of the challenges that you face in the data protection of data on virtual machines. Now, as we all know, virtualization brings a lot of benefits to a data center. You have the ability to optimize server utilization so that there is less server sitting idle and more applications that can run on less number of machines over here. The problem with that is that introduces a lot of challenges as far as protecting the data that's actually running on the virtual machine. Now, if you look at a typical backup environment in a traditional data center, you would have one agent sitting on top of each physical machine that's actually backing up data on a periodic basis. Now, in the case of virtual environment, that's a little bit complicated because backup processes require some CPU cycles. Now, because of having all of these virtual machines running on this ESX servers, the CPU utilization on this servers is already pretty high. And when you introduce this element of backup into the virtual machine environment, the CPU utilization is going to shoot through a roof, and you will probably have issues where backups don't complete, or if they do complete, they don't complete in time. So the solution, or one of the options to kind of mitigate this issue, to make sure that the CPU utilization does not exceed what's available, is to host or offload the backup processes from ESX servers to a secondary server. Now let's look at how you do that. This is a pretty simple diagram of how a small virtual environment would look like. You have two ESX servers over here, and each of them is running a bunch of virtual machines. Now, each virtual machine is represented as what we call a VMDK file in the shared storage. Now, a VMDK file is nothing but a representation or a blob of data that represents that virtual machine. Now, in most environments, you would have the storage shared between multiple ESX servers. It's typically a SAN, but it's not necessary. You could have it on other network attached storage as well. The point is it's shared across your ESX servers, and the VMDKs are available to all the ESX servers in the environment. Now, in a typical backup environment or a traditional backup environment, you would put an agent on the virtual machine and you would configure it to back up its data. So the data flow in that case would look something like this, where I'm reading the data from the disk over here, moving it over the network to the virtual machine, and that virtual machine is then pumping it off down to the backup server over here. As you can see, this has two disadvantages. You're moving data over the network, number one, and number two, you're still utilizing CPU cycles on this ESX server. Now imagine if all of these VMs are doing this at the same time. The amount of data that's being transferred and the amount of CPU that's being utilized is bound to overwhelm the physical server over here. So one of the solutions is to kind of get rid of this process of moving across the network and offload it to a secondary server, what is commonly called a proxy server. In the case of VMware, there's an option to use what's called VMware Consolidated Backup. What it is an option to stand up your backup infrastructure on a second physical server that has visibility to the same storage across over here. What that means is all of the VMDKs that represent the virtual machines are also accessible from the VCP proxy server. Then your backup process becomes a little bit more straightforward in terms of data movement. All you're doing when you need to back this up is make sure that this machine gets quiesced, or so that the data on it gets flushed to the VMDK over here, so that it's in a consistent format. And then you move this VMDK file or the data within the VMDK file directly from the storage to the server, and from there to the backup to disk target over here. Now that does two things. It completely eliminates the movement of data across from here, and it completely eliminates the CPU utilization on the ESX server over here. Now, you could do this. There are two methods to do this. Even though this concept sounds simple, there are certain caveats to watch out for. Now, there are two options to do this. You could do what's called a full disk level backup. What that means is I'm taking this entire VMDK file, which tends to be from 20 gigs to whatever the size of the virtual machine is. I tend to move this entire blob as a single file over the network over here. That has some advantages. It is your DR copy. So if something happens to this virtual machine, I can just take this whole blob of data, bring it back, and virtual machine is available for use. The problem with that, or the disadvantage of that, is every backup I have to actually move the entire block across, because I cannot do what's called a differential backup or an incremental backup. I cannot back up just the change data over here. The other option with VCB is to use what's called a file level backup. What file level backup does essentially reads into this VMDK file, presents the file system as if the virtual machine is seeing it, and make it available on the proxy server over here. So if this machine has volumes which have drive letters C, D, and E, and all of them are part of this VMDK, when I run this process, the drive letters C, D, and E would show up on this machine, and I can back it up over here this way. It's a little bit better because that gives me the option of now doing incremental backups, because I have now the ability to figure out what has changed since the last time I backed it up. That also means that I'm not moving all the system state data, like operating system files, over and over again. I can selectively back up my data. Now, another thing to consider with VCB proxy, or the method of using proxy server, is recoverability. Now, typically, what most solutions would do is, when I have to recover a full image, or I have to recover individual files, I would read the data from here just back to this proxy server, and by some manual process, I have to actually move this data back to the virtual machine. Typically, that would be through a network share. Now, that has certain challenges. Number one, I have to actually know which virtual machine that file belongs to, or that data belongs to. And number two, ESX or VMware has this ability to move virtual machines across ESX. So, for example, I could have a virtual machine running here one moment, and then using a process of vMotion, I can actually have this virtual machine running on this server. The challenge is when I'm using this method, it's very difficult to keep track of where the virtual machine is residing and who has access to that virtual machine. When considering a solution, backup solution, or a backup and recovery solution with virtualization, one thing to watch out is for the ability to recover data directly back to each of these virtual machines over here. That will eliminate a two-step recovery process where you don't have to bring it back here and then manually copy it here. And number two, you are always aware, regardless of where this virtual machine is, you need to be aware of where it is so you can directly recover it back over here. Now, if you think about it from an administrator's perspective, as you scale this down or scale this across, when you roll out multiple ESX servers, each of them are running several virtual machines on it. And if you get a recovery request for recovering one or two files, imagine a backup administrator's difficulty when he has to find out not only what files he has to recover, but where does he have to recover to across this whole broad string. Anything that's aware of that can keep track of where exactly your machine is running at any given time will simplify the recovery process a great deal. To summarize, virtualization has many advantages in the data center, but it also presents a lot of data management challenges. There are methodologies available to mitigate the effects of server consolidation, namely the ability to offload the backup processes from the virtual machines to another proxy server. Things to watch out for when you consider this option is how much data you're going to move across the network versus using this proxy solution over here. What is the recovery time? In other words, how long does it take you to recover data from your backup target, and how many steps does it require for you to do that? When choosing a backup solution or a backup and recovery solution, it's important to consider not only how long it takes up to backup data, but how quickly you can recover data from your backup to disk target to any virtual environment.